Hello students, now I take the change of state. State or phase change. You know that matter has three states: solid, liquid and gas. And before gas we have the vapors, so called the vaporization. So when the solid converts into liquid and liquid into the vapor, or the reverse of it, the vapor into the liquids and then liquid to solid, or solid to vapor and vapor to solid. This kind of transition is called the phase transition. The matter has three states or phases. Number one, solid. Number two, liquid. And number three, vapor oblique gas. So conversion of the substance from one phase to another is called the phase transition. Phase change or phase transition. When substance changes from one state to another state without change in temperature, it is called change of state. Or phase transition. So you know that the solid converts into liquid at a certain temperature called the boiling point, and liquid converts to vapor or gas at a certain point called the from solid to liquid it is called the melting point, and from liquid to gas it is called the boiling point. And then we have the change in the reverse order. So now you can see, now we have this solid, this changes into liquid, liquid into vapor. So this change takes place at the boiling point. So this is the called the liquefaction. fusion, and this is called the boiling. And then we can have this vapor to liquid and liquid to solid. So vapor to liquid, it is called liquefaction. And from liquid to solid, it is called solidification. Now we can have this solid into the vapor. Solid into vapor. Then this is called sublimation, or if we have like this from vapor to solid, then it is called sublimation. So this is called the change of state or the phase transition. During the phase transition, there is no change in temperature. Even the heat is required continuously till whole of the substance does not change into the another state. Suppose, for example, we take the solid. So suppose you have 1 kilogram of ice and you want to convert it into the water. Then until the whole of 1 kg ice is not converted into the water, the temperature will remain the constant. So what happens when this phase change takes place? Actually, in this situation, whatever heat is given, the temperature is not rising at all. The heat is given that acts, that is used in 2 cases. During change of state, the temperature does not rise. Even heat is given continuously till whole of the substance does not change. In another state. Another state. So during change of the heat given is utilized in following ways. Number 1, it increases. It changes the volume of substance. You know that when the solid melts into the liquid, the volume increases, and when liquid changes to solid, the volume decreases. So during the phase transition or the change of state, whatever heat is given, first it changes the volume of the substance. So it is used to increase the distance between the molecules of the substance. Second, it is used to work done against constant during the phase change. The temperature remains, the pressure remains constant. So when the volume changes, it means that work will be done at the cost of the pressure. Third, the heat imparted is used to increase the internal energy of substance. This you can see that since suppose for example we take the solid converts into the liquid. In solids the atoms can only vibrate. They cannot move from one point to another point. So they have very large interatomic forces. When this changes to the liquid, it means that the energy will be used to increase the energy of the molecule. As the molecule in liquid state, molecule can move in all directions with all possible velocities in the within the liquid. So it means that it has more energy than the energy of the solid. So this is what that the internal energy of the substance increases. Similarly, when we have the change from liquid to solid, then it means that the forces that are acting between the molecules will increase and the space or the volume of the substance will decrease. So whatever heat is given at the time of phase transition, it will be used, it changes the volume of the substance and it is used to work done against the constant pressure, and heat imparted to is used to increase the internal energy of the substance. It may increase or decrease the energy of the substance. When it is cooled, then energy decreases. Increase or decrease the internal energy of the substance. So in this case, temperature does not change, but only the phase changes. The boiling point and the melting point, they are also affected by the impurities. For example, if suppose you have the ice and just you mix the salt, the temperature will more reduce. So it will melt at a somewhat lower temperature than 0 degree centigrade. Similarly, boiling point, if you add some impurities to the liquid and just you heat it, then the boiling point will increase. So boiling point and melting point. Though the melting point does not depend upon the pressure, but the boiling point depends upon the pressure. If you just you can have that the atomic pressure is different at the different places, so the boiling point will be different. At the altitudes, the atomic pressure is very less, so the boiling point reduces. This is why that it takes more time to cook the vegetable, etc. at the altitude. The boiling point and melting point are affected by impurities. Boiling point increases due to impurity, and melting point decreases or reduces due to impurity. The boiling point is also affected by pressure. More is pressure, more will be boiling point. So, and vice versa. So this is why that boiling and melting points are also affected by the impurities and by the, though this melting point is not affected by pressure. The melting point is not affected by pressure. So this is all about the phase transition, or simply the change of state. So one thing is very clear, then when the state changes, the temperature does not rise, so the specific heat is infinite. When the temperature, remains constant during the phase transition, the heat is required continuously till whole of the substance does not change into the another state. It means that this energy is being utilized somewhere else inside the substance. First it increases the volume, it means that the distance between the molecules or the atoms increases. So interatomic spacing is increasing. Moreover, the intermolecular forces are also reduced. When volume increases or decreases, then work is done at the cost of the constant pressure. And whatever there is all these substances during the phase transition, the internal energy of the substance also increases, because in place increases or internal energy of the substance increases or decreases depending upon the change. When we go from solid to liquid and liquid to gas, then we have to increase the temperature. But if we do the reverse of this one, gas to liquid and liquid to solid, then temperature is to be reduced. The internal energy will reduce. So there is change in the internal energy of the substance during the phase change. So you like this video, share and subscribe. Thank you.